we'll do some more exercises here on a review. I've already done day one, so on the advent of code. So if you're interested in that, you can go ahead and watch one of the videos from the other sections. I forget what it involved, but it basically just involved adding up a bunch of numbers from a file. Day two here, I've already read it. It's a little bit more complicated, but it's basically very similar. I'm not going to go through the entire thing here, but basically it's a rock, paper, scissors problem. And so basically there's this strategy that they give you. So for example, suppose that you were given the following strategy. A, B, and C are rock, paper, scissors, right? I think, hopefully. Yeah, A for rock, B for paper, C for scissors. The second then the second column is what you should play in response. So X for rock, Y for paper, and Z for scissors. So the first column is your opponent, and then the second column is you. And so it's A, B, C, and X, Y, Z. Now, the strategy, if you played this strategy, what would the score be? So the score is based on the following. First of all, you get some points for whatever shape you selected. So 1 for rock, 2 for paper, 3 for scissors. And then plus the score for the outcome of the round. So if you lost, you don't get anything, right? If you tied, right, rock and rock, or scissors, scissors, paper, paper, then you get 3 points. Otherwise, if you win the round, then you get 6 points. So as an example, in the first round, our opponent picks rock. It says that we should choose paper, standing for Y here, and we win, right, because paper covers rock. And so we get a total of 8 points. Why? Because 2, we chose paper, right? Again, 1 for rock, 2 for paper, and 3 for scissors. And then we also won the round, so we get those 6 points. In the second round, let's see, where are we here? We choose paper, and so, or they choose paper, excuse me. And so we should choose rock X. This ends in a loss for you because of a score of 1 plus 0, right? So we just get the points for our choice, but we lost, so it's going to be 0. In the third round, we both choose scissors, right? Scissors, C, and Z, scissors. So we get a score of, I get 3 points for choosing scissors, and I get 3 points for playing the game to a draw, right? Okay. Here's our actual puzzle input here. So it's a lot of things, right? Now, the first thing that you can realize is that there are actually only 9 outcomes, right? You have 3 choices for the first component, your opponent, 3 choices for the second component. So what you could do is you could go through and you could hard code all 9 of those values, right? AX, AY, AZ. BX, BY, BZ, and et cetera, right? So you could do that, but let's go ahead and write a full program here. We'll be a little bit more design-oriented with our solution here. So for example, I don't want to do things in terms of X, Y, Z, A, B, C. So what I'm going to do is I'm going to use a type def, enum, right? And my type def enumerated type is going to be a move, right? That move is either going to be a rock, let's see, what was the order? Rock, paper, scissors. Yep, rock, paper, and scissors. Rock, paper, scissors. Right, there we go. So that I can speak in terms of rock, paper, and scissors with respect to the game. Now, note here that I'm going to start at 1, 2, and 3. Why? Because I'm going to easily be able to look at the enumerated type and get my score for that move, right? See that we get 1 for rock, 2 for paper, and 3 for scissors. And so by using 1, 2, and 3 in my enumerated type, I'll be able to treat those as integers that I can add to my score, okay? The second thing that I want is I want to convert that X, Y, and Z, or that A, B, and C, into rock, paper, or scissors. So what I'm going to do is I'm going to make a function to do this for me, right? Get move. And we're going to give them a single character, C, right? And that C, if C is equal to A, right? Or C is equal to X, that means that we're going to return rock, right? Remember, A is associated with rock. Let's see, come up here. A is associated with rock, B for paper, C for scissors. And then likewise, X for rock, Y for paper, Z for scissors. So I'm going to write these as convenience functions here, right? If it's, there we go, else if, there we go. Let's see. If it's B or Y, then I will convert that into a paper. There we go. Else, and I'm going to make this into an if statement here because I want to make sure that I am doing error handling properly, right? That if you have something that is not A, B, C, or X, Y, Z, then you should be, printing an error message or something like that. Printf, error, invalid, input. C is equal to %C and the line. Right? Just as a sanity check here, and make sure that you're returning rock, paper, scissors. There we go. Okay. So when I read this file, right, read this line by line by line, then I'm going to be able to convert those into actual moves that will allow me to think in terms of rock, paper, and scissors, right? In addition, I want the score of a game. So for example, get score. Right? If my opponent move, right, move opponent, and my move, my opponent move, my move, I don't know how you want to, opponent, me, right? I don't know, whatever, right? I want to be able to make a score here. So int score, and I'll initialize that to 0. Now, first of all, my move, no matter what, if I'm going to win, lose, or draw, I'm still going to get points for whatever move I make. 1 for rock, 2 for papers, and 3 for scissors. And now again, because of my choice of enumerated type here, all I have to do is, instead of initializing this to 0, all I have to do is add my move, right? And I get 1 for rock, 2 for paper, 3 for scissors. Now I have to determine if I won or not, right? So let me take care of a draw, first of all, because that takes care of 1/3 of all possible outcomes to begin with. If my opponent's move, opponent, right? Opponent, right? If that's equal to my move, right? Now I'm regretting me. Let's go ahead and go with my move. There we go. My move, right? So if we have the same, then what's the outcome? The score plus equals, I get 3 for a draw, right? Remember, I get 3 for a draw, right? I get 0 for a loss, and I get 6 for a win, okay? Now, all we have to do is determine if I win or not, right? Else if I win, then my score will be adding to 6, right? Otherwise, if I lose, do I get any points at all? No. So I can actually go ahead and leave off that return score here, right? I can leave off all that logic, right? The 3 outcomes in which I lose, I don't get any points for that. So I don't even have to write that logic. All I have to do is determine how I win, if I win, right? So what are my 3 winning moves? If my move is equal to, say, rock, right? And how do I win if my move is rock? My opponent's move needs to be what? Rock defeats what? Rock defeats paper? Yeah, scissors, right? Scissors, right? Or, what's another winning condition? Yeah, what if mine is paper, right? And my opponent, then I would defeat my opponent if they are rock. And then what's the other winning move? Rock, paper, scissors, right? I beat paper, right? Now, if it's any of those, then I've won. I'll go ahead and leave it like this. Right? I've won, and I get those 6 points. Otherwise, else I lose, right? Win, lose, or draw. Those are the only 3 outcomes there. And by looking at this equality here, I am ensuring that I'm taking care of all 3 possible draws, right? In which case I get 3 points. Otherwise, I get 6 points. Otherwise, I don't get any additional points other than what I started with my move. Okay? If you want to, we can do some ad hoc testing here. For example, printf, what should the score be if my, let's see, score is equal to %d and the line, get score of, if I put in rock and they are scissors, or sorry, they are rock and I'm scissors. There we go. Or we could actually just go with the 3 here, right? This is the first round, your opponent chooses rock and I choose paper, so let's do that one. Rock and paper. There we go. What's the other one? Let's see. That's going to be, in the second round, your opponent will choose paper, and then we have rock. So paper and rock. In the third round, we've got a draw with both players choosing scissors. All right, so scissors, and scissors. All right. Now remember, the outcomes of each one of these is 8, 1, and 6. All right, so let's go ahead and compile this. Day 2. And if my logic is correct here, we should have 8, 1, and 6. Hey, cool. All right. So I'm pretty confident that we have at least the building blocks that we can now start this, this exercise. Remember, it's not just 3 moves, it's this many moves, however many it is. So let me cut and paste this and put it into a file over here. And I'll call it, I don't know, day02.input.txt. Right? Yeah. So 2,500 moves here. Okay? Let's go ahead and get rid of that last empty line. Okay? All right. Instead of testing, we're actually going to read that file now. All right? Help me out. What would you do? I want to open up this file, this day2.input.txt, and I want to process it line by line, getting that first character, skipping that second character, getting that third character, forgetting everything else. What would you do? All right, right, immediately go to file, f is equal to fopen, ... right? But it sounds like you've done that before though, right? Hack 10? Why don't you just go back to hack 10 and reuse your code from that? Right? That's why we write functions, so that we can reuse them. And I've already done that. Right? Remember that hack 10 has this get file lines, right? So I'm going to use that over here. I'm going to include my file utils.h. Okay? And then down here, I'm going to go ahead and call that function. Right? Lines is equal to get file lines. The file that I'm going to be processing is day02.input.txt, right? And I want to know how many lines there are, and so I will pass in num lines, which means I need that int num lines, right? Is equal to, or it's going to tell me how many lines there are. Okay. Now, what I need to do is I need to go through each line. For int I equals 0, I is less than n, I plus plus, right? Or num lines, excuse me. There we go. Now, for each potential game, I've got something that looks like this, A, Z. Let's just go ahead and copy this over here to see what it looks like. Right? Now, each line is going to be a string. I want that first character, right? Char, opponent, char is equal to lines of I. Now, how do I get that first character in that in the ith line? 0. Right? What about my character? My char, right? Is going to be lines of I 1. Nope. This is the character at 0. This is the character at 1. That's space. And then this is the character that I'm interested in, which is 2. Right? Now that I've got my character, my opponent's character, my character, I can convert those over to moves because I already wrote that function. Right? I was forward-looking. I designed this well because I thought, okay, well, I'm going to have to convert these characters over to actual moves, and I want to think in terms of rock, paper, and scissors rather than A, B, and C. Okay? So move, my opponent move, right, is equal to get move of opponent character. Right? and move, my move is going to be get move of my character, char. There we go. And then I need the score, right? Int score is going to be, I already wrote that function, right? My opponent's move, opponent move, and my move. There we go. And what am I going to do? It wants the total, right? So if you were to add these all up, 8, 1, and 6, you get a score of 15. What is your total score if everything goes exactly according to your strategy? Okay. So I'm going to do some debugging here first of all, or some helpful print lines, because you only get one. You get more than one chance here. You can go ahead and mash the keyboard and put in a wrong answer if you want to, but then it starts throttling you and it makes you wait for a minute before submitting a second solution. So I want to make absolutely sure here, right? Number of lines is equal to %d, or number of lines, number of games, right? Num lines. Right? Remember that we should be expecting how many? 2,500, right? We should be expecting 2,500 moves, right? And I want to sum them all up, right? Int, or grand total plus equals score, right? And so I need a variable for that, grand total, right? Is that enough, by the way? Look at line 50 and tell me, is that correct? Oops. Anybody have any opinions on line 50? Always initialize it to 0. Right? Always initialize your stuff. Okay? So let's just go ahead and run this and see if we actually get a, grand total. What's wrong? There we go. Right. Oh, and then get file lines. I need to go ahead and compile my file utils.c. There we go. And gcc file utils.o and day02.c. There we go. Now I can run this. Uh-oh. Double free or corruption out of, wow, cool. Is there something wrong with my file, get file lines? I thought I copied this from a valid solution, one of my valid solutions. If not, then let's go ahead and run valgrind for this. So GCC with the G flag, GCC with the G flag, so that we can at least ask valgrind, where are we failing here? Valgrind a.out. There we go. 3 errors from 3 different contexts. Yeah. I'm not concerned about memory loss here. Yeah, it's happening in get file lines, unfortunately. Darn it. Anybody see what's wrong? It's day2 input.txt. Day02 input.txt. On line 55. All right, fine. Let's go there. 55. Ooh, string deep copy. Okay. Chomp out that inline character. Let's take a look at string deep copy. That looks good too. Darn it. All right. I don't want to debug that. So let's just go ahead and go back to basics here. All right. Go ahead and get rid of this dependency on the hack 10. I don't know where I copied that from. I might have copied it from like an intentionally buggy one in order to troubleshoot the grader or something like that. So let's go ahead and do our own file IO. Right? So let's go back to your idea of, let's go ahead and create a file pointer, open, and I'm going to be opening up in the current working directory day02.input.txt. There we go. And I'm opening it up for the purposes of reading. Okay. I'll still have a grand total here. I could hard code this since I've only got one input. I know that I'm only going to read 2,500 lines here. So I could go ahead and say num lines is equal to 2,500 and kind of cheat here. Right? And after I'm done with it, if I close the file, And now what I'm going to do is, instead of immediately assuming that it's in lines of 1, I'm going to go ahead and call forgets, right? And I'm going to put it into a buffer, right? And of size 100, 1000, whatever. 100 is big enough, F, which means that I need to create a buffer. So char buffer of size 100. I will read into the buffer at most 100 minus 1 characters, right? And then once I've got that, then buffer sub 0 and buffer sub 2 are my 2 characters. That should be good. All right? Questions on that so far?
Could the buffer be something like 10?
Yeah, in fact, it could be 1, 2, 3, 4 for the endline character, 5 for the null terminating character, right? And you'd be good. But I'm not going to risk it. Darn it. I need to go ahead and go with int numlines. CCC. All right, and let's just go ahead and run it straight. There we go. There's the grand total, 11,150. I'm not going to put that in yet, because what we should do is we should also test that this one's working. Remember that this has a value of 15. So let's come over here and replace our input with that. Save it. Rerun it again. Uh-oh. Now oh, 2,500. Now I need to kick this down to what? There's only 3. Right. GCC this again. Run it again. 15. Right. Undo to restore my own input, right, that I got from Advent of Code. Restore this to 2,500. And what was it again? Actually, I don't need to recompile. I'm confident that that's correct now. Right. This is the first time I've done it, so we're doing this live here. Right. Yay, I got it. I got 1 gold star. Okay. Now let's see what kind of corner I've painted myself into by doing this really quickly in ad hoc way, right? I do have some good design in here, in that I've got these functions, right? And then I'm doing an enumerated type here, and I've got functions that'll help me, but how is it going to be a little bit more difficult in part 2 here? So the elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means that you need to lose. Y means that you need to end the round in a draw. And Z means that you need to win. Good luck. So they've changed the rules on us. Okay. The total score is still calculated in the same way. Good, because I can reuse that. Right. That logic at least. But now you need to figure out what shape to choose so that the round ends as indicated. The example above, same example here, A, Y, B, X, C, Z, right? In the first round, your opponent will choose rock, and you need to end the round in a draw, Y, right? So you will also need to choose rock. This gives you a score of 4, okay? In the second round, your opponent again chooses paper, B, and X means that we need to lose. So, if they choose paper, how do we lose? How do we intentionally lose from paper? We choose rock, right? Let's see, what does it say? And you choose rock so that you lose, and so there's the score. In the third round, you defeat your opponent's scissors with rock for a score of 7. Okay? All right, so let's come back over here. Because I did design this a little bit well, right? What I can do is I can go ahead and modify this so that I have get appropriate move, right? So in other words, you need to win, lose, or draw. So we need to actually take 2 characters now, right? Character C, A and character B, right? Let me call this my opponent's move. I could actually do move, right? Move, my opponent's move, opponent, right? And character, this is going to be X, Y, or Z. I'll say it's C, right? So C being, let me write this down so I don't forget it. Let's see. X means that you need to lose. X means need to lose, right? C being Y means we need to tie, I think it is, right? What was it? You need to tie, so end the round in a draw. Z means that you need to win, right? So Z means that I need to win. There we go. And so we're going to return a move based on those rules there, okay? Well, help me out here, right? If we need to lose, this is going to be way more complicated, right? Because, oh, no, we can simplify this. So what if C is a Y, right? We need to tie. What should I return? If my opponent gives me rock, if my opponent gives me paper, if my opponent gives me scissors, what do I need to return to draw? The same thing. Right? So if we need to tie, all I need to do is return my opponent's move. Okay? All right. So else if C is X, then we need to, uppercase X. We need to lose. So now here is where I'm just going to go ahead and go with a straightforward logic here, right? If my opponent is rock, what should I return? Again, I need to lose. So what loses to rock? Scissors. Right. Else, if the opponent is rock, paper, then I can return what? Rock, because I need to lose. Else, if opponent is rock, paper, scissors, then I need to return what? I need to lose, so paper. There we go. All right. Now, if C is Y, or Z, we need to win. Right? So let me go ahead and copy that logic. Now remember, if they've got rock, we need to defeat rock. What do we give them? Paper. All right. They give us paper, we need to defeat that. So it's going to be scissors. If they give us scissors, we need to defeat that, so that's going to be rock. By the way, there's probably a trick here using modular arithmetic, right? You can 0, 1, and 2, 0, 1, and 2. You can probably do a difference trick of some sort if you just figure out the math really quick and get this down to a one-liner, right? Otherwise, there we go. So there's my appropriate move now. So this is day 2, or this is part B. So let me go ahead and come down here and see what I need to modify now, right? So this is the opponent's character. That doesn't change the opponent's move, but here's my character, and now I'm not going to get my move. What I'm going to do is I'm going to get the appropriate move based on my opponent's move and my character. Right, there we go. And then the outcome stays the same. And there's the grand total. Once again, let me go ahead and grab that test input here. A, Y, B, X, C, Z. And under these conditions, the sum should be 12. Right? So there's the 3. I did take it down to 3. Grand total should be 12. Thought I compiled it with, oh, okay. I can compile it. I'm not using it. There we go. 15. Was that correct? It should be 12. GCC day 02.c. Okay, why is it not changing? Darn it. This is day 2. Now I'm going to have to do some debugging here, aren't I? Darn it. Get appropriate move. Let's review this really quick. Oh, duh. What should I be doing this entire time? Using the wall flag, right? What is it warning me about on line 29? Typo. There we go. Let's see if that changes things. Right? Get appropriate move and get move. It's griping about that because I've got this last condition here that says invalid input. But if I ever see that, I'm not going to trust the output anyway, so no big deal. Right, there we go. 12, is that correct? Looks like it to me. So let's go back over here, restore my actual input, restore the 2500. Where is it? 2500. Right. Let's get the score on this. 82.95, and let's just be cavalier about it. Cross your fingers. Ah, wonderful. Right. I don't know. There should be leaderboards. Yeah, we're not going to be leaderboards, of course, because this is like, what, 8 days ago, or 7 days ago, right? But there's a top 100 scores right now, right? Okay. So, any questions on that so far? Right. So, good design means that we could, change just one function call, write a new function, and I didn't really have to change much over here. Oops. Change much over here in my actual program, right? The rules changed, so all I had to do was change this one function call, write that new function with more complex logic. And again, you could probably figure out some math to go along with this and get everything down to a one-liner on all that logic. I only took a half hour there. Right. Do we want to do another one? Yeah, keep going. I did read this one really quickly just to see what it looked like. It's going to be string processing, or we could redo day one here, which might be a little bit more helpful with respect to searching and sorting because there is a searching and sorting solution for it. Yes? No? Okay. Hey, good. I erased everything already. Excellent. All right, so let's get rid of all this. Okay. So let's read day one. Right? And again, I've already solved this, so I've got the solutions down here. Yay. Oh, that's just match point. Sorry. I'm also watching the scoreboard for the Nebraska volleyball game here. Right? So they're going to win along with us winning these stars here. Right? So anyway, the setup here is that you're just given a bunch of numbers. In fact, here's what my numbers look like. You can still get your puzzle. It looks like this. Right? So it's all language. All of these exercises are language agnostic. In other words, you can write them in any language you want because all it asks for as output is one single number, and then it always gives you this textual input here. Right? So what the interpretation of each one of these blocks is that this is a bunch of calories that one ELF has gathered. You need to sum those up. Right? Then you need to look at the second sum. There's the second ELF. The third sum, that's the third ELF. This fourth ELF here only found 2 things worth that many calories. Right? This 1, 2, 3, fifth ELF here only found 1 thing worth that many calories. And basically what it's asking you to do is go through and find, at least on part A here, is find the ELF carrying the most calories. How many calories is that ELF carrying? So for this one example here, the first one is carrying 6,000. Second one's carrying 4,000. Third one's carrying 11,000. This one's carrying 7, 8, 9 is going to be what? 24,000? There we go. And then 10,000. Your answer would be 24,000 because it's that third ELF there that has the most calories. Okay? I've already got my input here. I've got the tester input here, and I've also got my actual input here, which has not changed. Okay? So now, the other day I was talking about you could, you could make this a little bit quicker by modifying the input so that you didn't have to do file I/O. Right? Do we want to do it that way, or do we want to go back and actually do some file I/O on it? File I? Okay. File F is equal to fopen. Right? In the current working directory, day 01. We'll start out with that test data. Right, because, of course, we always test and then we submit our answer. Right? There we go. I'm going to open that up. I'm going to establish a buffer, char buffer. Here, I'll still make it 100, right? That's big enough, right? And then I'm going to make the first call to get that first line there. So char star line is equal to forgets. I'm going to get the entire string on that first line there, read it into buffer, at most 100 minus 1 characters because it puts the null terminating character in there for you, f. Right? So I'm going to read that first line, the first line, dot, dot, dot. Right? While we're not at the end of the file, right, that means I'm going to go into a while loop. How do I determine whether or not forgets is at the end of the file? What's it going to return when it gets to that end of the file? The only thing that it can return, which is well, EOF would be a special character. Right? This is a pointer, so the only thing it can return is null. Right? There we go. While it's not equal to null, then we keep going. Right? While we're not at the end of the file. Okay? So we've already read one line in here. We now need to do something with that line. What would you do with this line? It's an integer. So 4887, you convert that over to an integer, right? A to I of the current buffer or line, right? And then set yourself up for the next iteration of this while loop, read the next line, dot, 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 right? Print that, or line is equal to forgets, right? And buffer 100 f. There we go. So let's just make sure that I'm doing this correctly by doing some ad hoc testing here. X is equal to %d and the line x. Right? We haven't done anything yet except for process the file. But I want to make sure that I'm processing the file correctly. Right? .c. There we go. A dot out. There we go. So there's the contents of the file as represented by integers. Right? And again, we're doing the test file here. So 1,000, 2,000, 3,000, then 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. Remember that these zeros, those are those blank lines. That tells me when a different elf's summation has started. Right? So that's going to be my flag value right there. That tells me when I should be summing this up, summing this up, summing this up. Oh, a new elf has entered the game. Right? So we're going to restart our summation, sum this up. Okay, now a new elf has started, has come in. We're going to sum this up, and we're going to keep going. Okay? So, instead of printing it out, let's look at that logic. Right? If x is equal to 0, then we've seen, we've encountered a new elf, dot, dot, dot. Right? Otherwise, if we're still on the same elf, what should I be doing? Running total plus equals whatever x is. That means that I need to establish this variable, right? Right? So let's go ahead and come up here and have a int running total, and always initialize your variables, especially if you're doing a sum, right? Garbage plus 1 is still garbage. So 0 plus 1 is 1. Right? Okay, so otherwise we have a running total here. Now what happens when we see a new elf? Let's just look at this input right here. Right? We've summed 1,000, 2,000, 3,000 for a total of 6,000. We now see a new elf here. Remember what our final answer here is? We need to find the elf with the most calories. Right? So in addition to having a running total, I'll have a max, right? Which I'll initialize to 0 here because any calories is greater than 0. Right? So if the running total is greater than the max that I've found so far, then I will update the max to be running total. Right, there we go. What else do I need to do? I'm on a new elf. Should I be keeping the 6,000 that I've summed up so far? Nope. So what should I do with my running total? Set it back to 0. There we go. At the very end, if I close it, right? If I close F, right? and report the maximum value. Printf max value is equal to %d and line max. Now, for the testing, this should be 24,000. Yay, I got it. All right. Just make sure that this is, yep, this is good. All right, let's go ahead and switch it over to the actual input over here and see if it works. Input, GCC. Yay, 68802. Again, I already submitted this yesterday. There's my answer, 68802. Right. So we successfully did this twice in a row now. Right. Now, here's where the kicker comes in. Right. Part 2. By the time you calculate the answer for the ELEVS questions, they realize that they want some redundancy here. They might run out of snacks. So it doesn't want you to just report one max. It wants you to report the top 3 ELEVS carrying. In other words, the 3 top values. Right? So in this particular case, if we go back up here, 24,000, 10,000, and 11,000. If you sum those all up, you would get 45,000. Right? Yeah, 45,000. It wants the top 3. I'm not sure how many there are here. Right? Over here. I could go through and count up, you know, the number of blank lines here. Right? And then that would tell me how many ELEVS there are. And then what I could do is I could store them in an array. Why would that help me store them in an array? Oh, why would that help me? If I had, say, 6,000, 4,000, 11,000, 14,000 or whatever it is, and 10,000. If I just had an array of all the totals, how could I get the top 3 values? Sort it, right? That's what I'm going to do. So, I don't know how many ELEVS there are here. What I could do is I could write some code to go through and count up the number of blank lines, right? I could go through it twice like you did with the file IO exercises, right? I could run through this file once, count up the number of blank lines, and if there were 4 blank lines, that tells me that there are 5 ELEVS. Why? 1, 2, 3, 4, but then that's the gaps in your fingers. How many fingers do you actually have if you have 4 gaps? 5, right? I'm not going to do that. Instead, I'm going to now show you some of that regular expression magic. Find caret, $sign. Oops, $sign. There we go. Right. How many blank lines are there? 251. That tells you how many ELEVS there are. How many ELEVS are there? 252. Ooh, that's magic. Right? That's a regular expression. The caret matches the beginning of the line. The $sign matches the end of the line. Right? And what's in between? Nothing. Right? So that tells you how it's matching every single blank line here, and they're all highlighted. What if I want the opposite? What if I want every line with a number on it? 0 through 9, star, 1 or more. Right, there's another regular expression. 0 through 9 with the square brackets there, that's a set. I want anything 0 through 9, and then the star says 0 or more occurrences of it. Oh, wait a second. That means it's counting the blank lines too. Why? Because 0 or more occurrences, right? Okay, that's not what I meant. I meant that you have to have a number on that line. Plus is 1 or more occurrences. Now, how many numbers do I have if I wanted to read those into an array? 1,998, right? Very, very powerful regular expressions here. Here's another one. Not 0 or more or 1 or more, but exactly 1. There are no results. Why? They're all at least 4 digits. Okay. 1, 2-digit numbers? None. 3-digit numbers? There are none. 4-digit numbers? There are 1,779 of them. How many 5-digit numbers are there? 219 of them. How many 6-digit numbers are there? None. Then there are better ways of doing that. I think that you can encode that, isn't it? Without having to repeat it. Right? Let's see. Can I do a replace too? Yeah, I can. All right, so all those numbers, Actually, I don't know. Let's go ahead and replace all blank lines with hello. There we go. That'll be my flag value, right? Let's replace all of them. There we go. Oh, and oh, darn it. All right, so I don't want those, apparently. Replace all those, right? Undo, because I don't actually want to do that. But I could replace them with, say, zeros, right? And replace all those. I could replace the beginning and end of every line with, say, a comma, right? And then, well, sorry, no, what do I want? 0 through 9, sorry, 0 through 9, one or more occurrences, one or more occurrences, and then I'm going to replace that with whatever I found. Yeah. There we go. Whatever I found, I want to replace that with the same thing, but then a comma at the end. Why would I want to do that? Because now what I can do is int array is equal to this. Do I need to do file IO now? Nope, I've got a nice static array here that's already initialized, and we're good to go. Right. Now let's eliminate all white space. One or more occurrences with nothing, replace all. Nope, what's white space? Is it B? Nope. What is it? W? Yeah, there we go. Let's find out. No. What is S? I think it is. All right, fine. N-line characters. Replace all n-line characters with nothing. There we go. And now I get it all in one line instead. Yay. Let me back all this up. All I wanted to do was show you some regular expression magic so that you can think in the future, wait, you know, there is this tool that I saw one time called a regular expression that could probably get this done in a matter of seconds, right? I'm going to go back and learn more about that and use that and then learn how regular expressions work and then use that going forward. So it's a very cool tool, very powerful tool for you to use in the future. Right? It goes beyond the scope of this course, though. Okay. Anyway, back to the matter at hand here. How many totals did we have again? 252, I think. Right. And so I'll establish an index variable here at 0. Right. Every time we encounter a new elf, I don't want to look at the max yet, right? Instead, what I want to do is I want to put that total into my totals. Totals of I is equal to running total. There we go, I++. And then I'll reset the running total here to 0 so that I can continue adding it up, okay? Running total. There we go. We're done with that. I'm not going to print the maximum value anymore. What am I going to print? I've got an array of totals. What do I do now? I need to sort it. I need to sort my totals. Remember that there are 252 things in it. How many bytes does each thing take? They're integers, so size of int. And then CMP int. If you want the maximum values at the top, right? Then you're going to be sorting in descending order. So let's go ahead and call it descending. Now, if that function was already available to me, what I could then do is report printf max is equal to %d end the line. That guy is going to be in totals of 0. Now, if you want the top 3 maximum values, right? Top 3, then it'll be totals of 0 plus totals of 1 plus totals of 2. I'll report both of them at the same time. We're not done yet because I haven't written this comparator. Help me out. What does a comparator look like? It returns an integer, right? Does it take 2 integers? Nope. It's const void star pointers. Right? And const void star pointer. Right? Now, we do need to expect those to be integers, so I'm going to go ahead and convert them over to integers. Const int star x is equal to const int star a. Const int star y will be b. And now we can make, or y, sorry. And now we can compare those things, right? If the thing stored in x is less or greater than the thing stored in y, remember we're in descending order, so this is in order, so return -1. Is that how I do that properly? The thing stored in x and the thing stored in y. Is that what that, this comparison is doing? Nope, it's comparing pointer values. It's comparing memory addresses. What relevance does a memory address have with respect to what's stored in that memory address? None. Right? So let's dereference them to get the actual values stored in those locations. Else if x is less than y, print, or not print, return something positive. They are in order. Else return 0. Okay? Let's make sure that this works. Yay. Let's see if I'm still getting that that grand total correct. 6802. All right, I'm pretty convinced. And then 205,370. Or 205,370. All right. Searching and sorting. So now you see what the patterns that I was talking about, right? If you just do the one max, right, that kind of paints you into a corner because then it wants the next top 3. What if it wanted the bottom one, right? You'd have to add code onto code onto code. Whereas if I knew from the beginning that it was going to want like multiple values, I wouldn't have done that, what I did before. I would have put them all into an array, sorted that array, and immediately gotten the original first answer, but then also gotten the top 3 as well. And bottom 3, median, whatever else. All right, any questions? No? We could take a look at 3. I'll probably be doing it tomorrow in one of the other sections. It's a lot of string matching. So you're given these random strings. The letters there, they represent things that you're packing. And all you have to do is split it up into 2 halves. So for example, this first string right here, you would split that up into 2 strings. Let me go ahead and create a new file over here. New file, scratch.txt. Right. So where is the middle? I think the middle is right here. Yep, it is. Okay. So there's the middle, and what you're doing is you're searching for common things. For example, the first compartment contains those elements that I split it up in half, while the second compartment contains this. That's the second part. The only item that appears in both compartments is lowercase p. Right? Find p. Right? There's p. It appears in both those halves. Right? What about capital W? Nope. W appears in 2 of those things. In the first one, both uppercase and lowercase, but not in the second one. Likewise, M appears in the second half, but not in the first half. And so you need to find that guy. Right? You need to find that lowercase p that's common to both of those. We've got enough time to maybe do, I don't know. No, I'll save it. I'll save it for tomorrow. If you want to watch one of the other live streams, you can. On Fridays, I live stream at 9:30 and 2:30 in the afternoon down in Lincoln. And then we'll have a potluck right between, and so the 2:30 one might not be too interesting because I'll be full of food, right? And sugar, because everybody always brings desserts to potlucks, right? They never actually bring main dishes or anything. So I'm bringing a dessert. So I'll be full of cookies too. All right, any questions? No? So remember, your exam is what day? Tuesday, is it? The Tuesday of the 13th, is it? I don't want my whole calendar up on the live stream, so I'll do it over here. Let's see. Indeed, the 13th. Tuesday the 13th. We talked about it already, that it's going to be 2 parts. You have 24 hours, that 24-hour time period to do it. It'll open at 12:01. All this information will be repeated in the weekly Piazza post. Otherwise, good luck on the rest of your finals. Remember, today is your last day for that resubmission opportunity. I will not be over there because I've got something to be at 2 o'clock. But Carl, Adarsha, and probably some of the undergrad TAs will be over there to help you. You just need to demonstrate at most 1 lab and 1 hack of 5 through 12. They'll regrade it right there in front of you, update your score right in front of you, and today's your last opportunity to do that. You can head over there now. You don't have to go to the second session and wait for it. Usually, like on Tuesday, there were only like 4 people there, so you can go over there now if you're ready to show it. Right. Otherwise, good luck on the rest of your finals too.